So now in this video we're going to make a really fun circuit. It is a single NPN bipolar junction transistor flasher circuit. So a flash in LED. And so to begin with, we're going to put the transistor backwards from how it normally is. Normally the emitter is to the negative rail and the collector is to the positive rail. And putting it in backwards for this circuit takes advantage of one of the weaknesses of it. So it does not block near as much voltage while it is backwards as when it is forward, or when it's connected properly, I should say. So in any case, the transistor we're going to use is the 2N2222, an NPN type bipolar junction transistor. Here is the symbol, but the emitter is to the top and the collector to the bottom, which is usually opposite of what you see, but it doesn't really matter as long as you make the right connections. So we have the emitter left pin, base the middle pin, and collector the right pin. So we will turn it this way. Flat side will be to the left, emitter will be on top. We're going to put it to a 1 kilo ohm resistor up here. And now we have one space away from the negative rail right there. You can see we are going to put an LED. So LED is a type of diode. This one we absolutely have to put in the right way. So the anode heads towards the positive side of the power supply, cathode towards the negative. Right there, we will plug that in, and we need one more component, the capacitor, right there. So I'm going to use a 1000 microfarad capacitor. It's polarized. That side has to be more negative, that side there more positive, or we can discharge it fully too. And then no more than 35 volts. We're only going to deal with about 12 volts in this video, most specifically about 9. And so we plug that there and then over to there. So now let's zoom back a little bit, and so that we can see right there I have my bench power supply bring in power to the rail. It's set to 2 volts right now. We will get the meter in there and zoom in like that. So I'm just going to go to this side and measure the voltage there. And this circuit takes pretty much spot on 9 volts. So I'm going to rapidly go. Let's go about 8. There, you can see it's a little shy. I'm going to work the voltage up, and you can see at pretty much spot on 9 volts the LED started flashing. And even more interesting, let's go slowly, somewhat slowly, to 10 volts. You can see it rapidly starts flashing a lot faster as we get to 10 volts, and then 11 volts, and at some point it'll probably look like it's on steady but still be flashing. So in any case, doesn't look like it's going to look steadily on for a while. But in any case, that is a really easy circuit to put together. Pretty interesting one. And so I recommend making this one. This is the simplest way to flash an LED that I have come across. And mostly what it's doing is taking advantage. We leave the base floating, by the way. We don't give it a signal. I should have mentioned that earlier. You just leave it floating. So the transistor prevents current when the collector is more positive than negative to a much higher voltage than what it does when it is going from positive to the emitter and collector. It breaks down easy. So even though it's NPN in both directions, we got N material, P material, N material, one side is made to withstand more voltage than the other one. That's why you don't want to use it backwards. As we saw before, with this transistor, at least until we hit 9 volts, it still blocked the voltage and current pretty much as normal with it inserted in the right direction. But once we exceeded that 9 volts, then it started conducting. If we turn it around, then you can see I just wired it exactly the same. This is how it's normally wired. Now it's blocking that 9 volts, no problem.